Ever wondered if the dark side of the moon is really in perpetual darkness? Well, let's shed some light on this lunar lingo. When we talk about the dark side of the moon, we're actually using a bit of a misnomer. You see, dark in this case doesn't mean without light, but rather unknown or unseen. Here's why: the moon, just like our Earth, rotates on its axis while orbiting the sun. This means that, over time, all parts of the moon are bathed in sunlight. However, because the moon is tidally locked to the Earth, meaning it rotates at the same rate that it orbits our planet, we only ever see one side from here on Earth. The other side, the so-called dark side, is simply the far side, hidden from our view but not from the sun's rays. So, it's clear, the dark side isn't dark at all. Has humanity ever glimpsed this dark side? Spoiler alert, yes we have. It all started with the pioneering Apollo missions, where astronauts orbited the moon, capturing the first ever images of the far side. These missions, although primarily targeted at the near side, gave us a sneak peek into the unseen lunar hemisphere. But it wasn't until the advent of unmanned lunar probes that we truly ventured into the moon's hidden side. The Soviet Luna 3 probe, for instance, photographed the far side back in 1959, providing us with the first comprehensive lunar atlas. In recent years, we've seen missions like China's Chang'e 4, which not only landed on the far side but also explored the Von Karman crater, gathering invaluable data about this uncharted territory. So, contrary to popular belief, we've seen the far side, just not from Earth. This has allowed us to debunk myths and shed light on the moon's most enigmatic face. Now, is the far side of the moon a mirror image of the side we see? Not at all. The two faces of the moon are as different as chalk and cheese. Geologically speaking, the side that we see, the near side, is filled with vast flat plains called Lunar Maria. These dark basaltic plains were formed by ancient volcanic eruptions. Contrarily, the far side is heavily cratered and rugged with a thicker crust. It's a riot of peaks, valleys, and ancient impact scars. But what's strikingly absent are those dark flat plains we see on the near side. Why such a stark difference? Scientists believe that the thinner crust on the near side allowed for more volcanic activity, leading to the formation of Maria. On the far side, the thicker crust suppressed such activity, so the two sides are as different as night and day, geologically speaking. Alien bases, hidden civilizations, the far side has been a fertile ground for theories, but let's set the record straight. While it's tempting to believe in extraterrestrial settlements or secret lunar bases, the scientific evidence simply doesn't support these ideas. Space agencies around the world have sent numerous missions that have mapped the moon's surface in detail. And guess what? No signs of alien life or hidden structures. Then, there's the persistent myth of the moon landing being a hoax. Despite overwhelming evidence, including photographs, rock samples, and the testimony of thousands of people involved in the Apollo missions, some folks remain unconvinced. But let's be objective. The moon landing wasn't a Hollywood production. It was a monumental achievement of human exploration. As you can see, while intriguing, these theories are more fiction than fact. So the next time you gaze at the moon, remember, it's a place of natural wonders, not secret alien bases or faked landings. What does the future hold for exploring this hidden lunar hemisphere? As we look to the future, space agencies around the world have their sights set on the moon's far side. The allure of the unknown draws us in, with the promise of unearthing new secrets about our closest celestial neighbor. Upcoming missions aim to delve deeper into the moon's unexplored terrain, seeking answers to age-old questions. One of the most exciting prospects is the search for water ice. This could not only revolutionize our understanding of the moon's geological history, but also provide a potential resource for future lunar bases. Imagine a base on the far side of the moon. It may sound like science fiction, but it's a very real possibility. Such a base could serve as a launch pad for further space exploration and a beacon of human achievement. Well, with these upcoming missions, who knows what secrets we'll unearth next?